In two of our previous sessions, we have seen top 10 basic SQL interview question and top 10 intermediate SQL interview question. In this video, we will see what are the top 10 advanced SQL interview question that are commonly asked in data analyst interview and other SQL related role interviews. So our first question is, what are window functions or analytical functions? Functions that perform calculations across a specified range of rows related to the current row within the result set. And it is particularly useful for performing calculations that involve aggregations or comparison with the neighboring rows. So that functions are basically called as window functions or analytical functions. And these are the commonly used window functions. The first one is row number, which assigns a unique sequential integer to each row within a partition of a result set. So window function will be acting with respect to a partition or a window with respect to the input data. And the second window function is rank, which assigns a unique rank to each distinct row within a partition of result set. And thence rank is similar to rank but assigns consecutive integers to tied rows instead of skipping rank. So in case of rank function, it will be skipping some rank when the values are same, but in case of dense rank, even if the values are similar, rank will not be skipped. We will see detailed example of rank and dense rank function in an upcoming question. The next function is entile function, and which will divide the result set into n equally sized buckets, assigning a bucket number to each row. And the next is sum, average, minimum, maximum, which are the aggregate functions and which can be used as window functions. Next one is lead and lag function, which access data from subsequent or previous row in the result set. And coming down, we have an example for window function where we are using the sum window function or sum aggregate function as a window function to calculate the running sum. Here we are selecting order ID, order date and total amount from the orders table. And in this expression, we are calculating the running sum or the cumulative total using the sum function, which is the aggregate function, but here we are taking the sum function as a window function. So we are calculating sum of total amount over and using an order by clause within the over clause based on order date and calculating the running sum. Similarly, window functions are having lot of application in our day-to-day analysis. Now moving on to our second question. What is the difference between rank and dense rank? Rank and dense rank both are window functions which assigns a rank to each row based on the value in one or more columns. Rank may have gap in the rank sequence when there is a tied value. In case of dense rank ensures a continuous sequence of rank number without any gap. So now we will see an example, then it will be pretty clear. So here is a marks column which consists of 10, 20, 30, 30, which is repeating 40, then 50 is repeating two times, and 60. Now if we are ranking the column marks based on rank, the rank will be 1, 2, 3, 3, which is corresponding to 30 and 30. Then we are skipping the rank 4. Then for 40 we are giving the rank 5. Then for 50 we are giving rank 6. Then for the next 50 also we are giving rank 6. And since we have given the same rank to two of the marks, we are skipping the rank 7 and we are giving rank 8 to mark 60. And when we come to dense rank, here rank 1, 2, 3, 3 is given to marks 30, then 4 is given to 50, 4 is given to 40, then rank 5 is given to 50, and again 5 is given to 50, and 6 is given to 60. And now when we compare the result of rank and dense rank, we can see that in case of rank, the numbers are skipped. When there are equal marks, we are skipping the ranks. But in case of dense rank, even when there are equal ranks and for multiple rows or multiple records we are giving the same rank, we are not skipping in a record. So in case of dense rank, the rank will be continuous. And in case of rank, there will be some breaks in between the ranks. So that is the basic difference between rank, and dense rank. The next question is, what is view and how it is different from a table? View is a virtual table that is based on the result set of a query. It does not physically store the data itself but provide a way to represent the result of a query as if it were a table. So this is the most important point, that is, it does not physically store data within the table or within the database. Key difference between view and table is, in case of storage, table physically store data on disk, while a view does not store any data itself. It is simply actually a query. And in case of data modification, directly insert, update or delete records in a table. Ability to modify data through a view depend on the complexity of underlying query and the presence of certain conditions. That is a bit advanced topic. Normally, we don't directly insert, update or delete records into a view query. We can insert data through a single table view if we have insert privilege on the view. So this is with respect to how we can insert data into a particular view. To do this, the defining select schema can select from only one table. So it is given that if the view is with respect to only one table, we can directly insert records into the view. And it cannot contain any of the following component. That is, if the view query consists of keywords like distinct, group by, or some kind of derived values or aggregate values, we cannot insert records directly into that particular view. And in case of structure, tables have a fixed structure. View derive their structure from select query which define them. Index and keys. Tables can have indexes, primary key, foreign key, and other constraints. Views do not have their own index or key. Instead, they rely on index and key of the underlying table. And coming to security and abstraction, view can be used to restrict access to certain columns or rows in the underlying table. They provide a layer of abstraction. That is, consider that we need to provide only certain columns from a table to our end user. In that case, we can use a view because other columns might contain some sensitive information which should not be present to the user. So in that case, we can use view so that we can create a layer of security or a layer of abstraction. And that gives us a additional layer of security. And for that purpose also, we can use view. Our next question is, what is CTE and where to use CTE? CT is temporary result set in a select, insert, update or delete statement that is referenced within the scope of a single SQL statement. CT are defined using the with clause. It makes complex queries more readable and easier to manage. And this is the basic syntax for common table expression. So we are using a with clause and this is the name of the common table expression, and these are the columns which we are taking from the CTE. Then inside the definition or the parenthesis within the with clause, we are providing the CTE query definition. This is the definition which tells us to select column 1 and 2 from the input table, that is some table, and we can give some where condition in the parenthesis, within the parenthesis. And after this, we can write any main query using the CTE. So this select star from CTE name is based on the CTE which we created using the with clause in the previous statement. Now this is particularly useful in various scenarios to improve readability, maintainability, and organization of complex queries. Also, code reusability and recursive CTE, we may use common table expression. So these are the common use cases of common table expression. Now moving on to our next question, which is, how do you enforce uniqueness in a column? So this question is with respect to constraints. Enforce uniqueness in a column by using the unique constraint. So we can use unique constraint to enforce uniqueness in a column. The unique constraint ensures that all values in a column or a combination of columns are unique across the entire table. And this is how we can create a unique constraint with respect to a column. So here is the basic syntax. So here I am creating a table. This is the table name, this is the column name, first column name and corresponding data type. Similarly, I am creating n number of columns, and here is the unique constraint enforced column, which is unique column name. This is the data type. And then after that we are going to provide the unique constraint. So once we provide this unique constraint here, this unique column name can only accept values which are unique. Also, once a table is created, we can add a unique constraint to an existing table using the following syntax. That is alter table. This is the table name to which we are going to add a unique constraint. Then add constraint. This is the constraint name. So it can be whatever name that we like. Then unique, which is the constraint. And here is the column name to which we are going to apply that constraint. And next is add unique constraint to a combination of column. That is, we can consider different columns as a single combination, and we can enforce unique constraint to that combination of column using the below syntax. Here we are altering the table name, we are providing the table name, then add constraint, unique constraint name, it can be whatever constraint name. Then we are providing the constraint which is unique constraint, and inside parenthesis we have to provide the different column names based on which we are going to consider that particular combination as unique. So this is how we can apply unique constraint to a combination of columns. Now moving on to our next question, where to apply cross join. Cross join is also known as Cartesian join. So people can also ask what is a Cartesian join, and it is used to combine each row from one table with every row of the another table. So it can be used to create combination, that is the first use case, and it can be used to create Cartesian product. So here in this example we are creating combinations based on table colors and sizes. So select star from colors table which consists of different colors, and a second table which is called as size table which consists of different size. So now here we are creating different color and size combination using the cross join. And here in the second example, we are creating Cartesian product. That is, we have a number set table, which is our first table, and the second table is number set two, which is our second table, which consists of different numbers. And now we here want to create a new table such that every numbers in the number set table one is combined with every other number in the number set 2 table. In that case, we will use cross join. So these are the two examples which you can explain if you are asked some examples for cross join. So the first one is generating combination, and the second one is creating Cartesian products. And now the next question is, how do you optimize a SQL query for better performance? And what are the four techniques? There are many techniques to optimize SQL query. Mostly it's based on what is the underlying query and what is our final goal, but these are very commonly used, and it can be applied to most of our use cases. So the four methods are, we can use indexes. Then the second one is limit the result set. So that is, instead of using select star, we may use select only the column names which are required in our final output. Then the next one is avoid select distinct. So instead of using select distinct, we may use group by clause to group the data or identify unique records from the table. And the final method is optimize join operations. So we may use appropriate joins and always try to join with bigger tables. So if we are writing a left join, consider that the biggest table or the parent table as the leftmost table. In that case also we can optimize our query. Next question is, what is the purpose of SQL pivot and unpivot operator? It is used for transforming data between a relational format and a cross tabular format. And the second one is useful to rotate rows in columns, that is pivoting, or revert, that is columns back to rows using unpivoting. And this is two examples of pivoting and unpivoting syntax. In this pivot example, as our final output, we will have product as the first column, then January, February, March, April, May, and June as our subsequent columns. That is, we have converted this month column month column into different rows, sorry, different columns. And inside we will have the, or the in as the combination of product and months, we will have values within the tables, that is sum of sales. And coming down, we have an example for unpivot function, where we are doing the exact opposite to what we saw in our previous pivot example. So here we are converting this month back into raw data. So in the first column we will have product name, in the second column we will have the column name as month, and the column values will be January, February, March, April, May and June. And as the third column we will have sales column. So our final output will have only three columns in this unpivot example. And when we come to our pivot example, in our final output we will have Jan, February, March, April, May, June, this six column plus one column which is the product column, that is seven columns we will have in our pivoted output. So that is the difference between pivot and unpivot. The next question is, how do you handle null values in SQL queries? The first method is using is null or is not null. Example is, we are selecting column 1 and column 2 from table 1 where column 1 is null. So whenever the column 1 is having some null values, only that particular records will be selected. In case we need records for which column 1 is not null, that case we will modify the query such that here column 1 is not null. So this is one method of filtering records using is null and is not null. Second one is using collies function. Select column 1, comma, collies. Inside parenthesis, we are specifying the expression or the column, comma, the default value. So whenever the column 2 is having some null value, the default value will be substituted instead of the column 2 value. That is the use of collies function. And the rest of the query remains same. That is as column 2, which is the alias name from table name. And the third function is null. This is similar to collies function, but collies can have many number of arguments, but in case of is null function it can only have two arguments. So is null column 2, which is the column name or the expression, and the second expression is the default value. So if column 2 is having null value, that time default value will be substituted instead of column 2 value. And coming to our next statement, which is the case statement. Using case statement also we can deal null values. So here we are selecting column 1, then we are writing the case statement, that is case when column 2 is null, then we substitute the default value, else the value will be from the column 2 only. And then we are ending the case statement and giving an alias name as column 2 from the table name. And the final function is null if. Select column 1, comma, null if, that is if column 2 is having some specific value, that is the condition. So if column 2 value and condition is matching, that time it will be substituted by null. So this is very commonly used in case of division. So whenever we are dividing some number like 1 by 0, that time it will become infinity. In that case what we are doing is we will substitute this 0 with the null if function, null if 0 comma 0. In this case this 0 will be substituted by null, that is 1 by null will become null itself, so that there is no infinity in our final output. So null if is very commonly used to deal with 1 by 0 error. Now we are moving on to the next question, which is our final question, that is, what is the purpose of SQL lead and lag window function? Lead and lag window function are used to access subsequent and preceding rows in the result set within the same query result. This is part of window function category. The lead function syntax is like lead, open and close parenthesis. We will specify the expression, which is the column name in most of our cases, and this is the offset value, that is the number of columns above or below to which we have to look. Then this is the default value. If there are no values with respect to that particular offset, we can take the default value as our final output. And then we have the overclose, and inside parenthesis we specify the partition by and the partition column and order by and the order by column, that is the column based on which we have to order our result. And similarly, we have the lag function which has the exact same syntax. Then this is an example of using lead function. So here we are calculating the percentage change. Query using lead to calculate percentage change. So here we are selecting product ID, month and sales amount. Now we are using a lead function on the sales amount column, and we are considering this column as the next month sales. And then we are calculating the percentage change. That is, this equation corresponds to next month sales subtracted by sales amount, that is the sales of the previous month divided by sales of the previous month, which is then multiplied by 100, which gives us the percentage change. And this is from sales table and order by product id and month id. And this query will gives us the insight into how sales amount change from one month to next month for each products. These are the top 10 advanced commonly asked SQL interview questions that you may encounter in any of the SQL interviews. Hope you like this video, and if you like, subscribe for more. Thank you.